Good morning, children. Quadrilateral chapter we are continuing here. P, Q, R and S are the midpoints of the sides AB, BC, CD and DA respectively of the quadrilateral ABCD. Prove that PR and QS bisect each other. So the important questions we are solving, already we have completed one video on quadrilateral. Now this is the second video. PQRS is the quadrilateral. Figure is not given, we have to draw the figure. So PQR is the midpoints of the side AB. So ABCD is the quadrilateral is given in that P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD and AD is the midpoint of, so S is the midpoint of AD, right? Now we have to prove that PR, that means diagonals, PR and QS are bisect each other. So we have to join PR and QS. Before that, what we should do means we should prove that this is a parallelogram, that which is one PQRS. So PR we are joining AC first, and moreover if it is a parallelogram, PR and SQ become the diagonals, right? So the diagonals of the parallelogram bisect each other. That concept we can use. So what is given here? ABCD is a quadrilateral. To prove PR and QS bisect each other, if they are bisect each other means we should prove that a PQRS is a parallelogram only, and if it is a parallelogram, PR and QS became the diagonal. So I should add here QS diagonals. Diagonals of the parallelogram bisect each other. So the diagram already seen. So construction part now. Join AC. Proof. P and Q are midpoints of the side AB as well as BC. So in triangle ABC, by midpoint theorem, what we can say, PQ parallel to AC, PQ equal to half AC. So I'll write here, by midpoint theorem, PQ parallel to AC, PQ equal to half AC. Similarly, SR parallel to AC, SR equal to half AC. Equation number 1, equation number 2. Using 1 and 2, PQ parallel to SR, PQ equal to SR. Therefore, one pair of opposite side of the quadrilateral PQRS is equal and parallel. Therefore, PQRS is a parallelogram. Now we should prove that PR and SQ are bisect each other. So if PQRS is a parallelogram and we join PR and SQ, because we can join it because it's a diagonal only. Now what we can say that PR and QS are diagonals of the parallelogram. PQRS. Therefore, it bisect each other. Hence proved. In the given figure, AD is the median of triangle ABC. E is the midpoint of AD. DG parallel to BF. Prove that AC equal to 3AF. Given AD is the median, or we can say that BD equal to DC. Next, E is the midpoint of AD means AE equal to ED, and also DG parallel to BF. To prove AC equal to 3AF. Proof. In triangle ADG, which is the midpoint A, E is the midpoint. EF parallel to DG. Therefore, F bisects EG. रीज़न क्या है? कॉन्वर्स मिड पॉइंट थ्योरम. That is AF equal to FG, equation number 1. Similarly, we can start with the, now we have started with the E is a midpoint and now D is the midpoint. So what is the triangle name changed here? It is the triangle BCF, right? So in triangle BCF, which is the midpoint D. D is the midpoint of BC. DG parallel to BF. Therefore, G is the midpoint of FC. Same reason, so I can write here similarly, or we can write here converse midpoint theorem. That is FG equal to GC. So from 1 and 2 what we can write? AF equal to FG equal to GC. Now we have to prove that AC equal to 3AF. AC means AF plus FG plus GC, right? All three are equal only. So what we can write? It is equal to 3F. Hence proved. In the given figure, D, E and F are the midpoints of the side AB, BC, CA respectively of triangle ABC. Show that triangle ABC is divided into 4 congruent triangles by joining D, E and F. So here given triangle DEF, the midpoints of AB and BC of the triangle ABC. Triangle DEF is formed by joining midpoints of AB, BC, sorry, it is a D is a BC only starting, BC, CA and AB respectively. To prove triangle ABC is divided into four congruent triangles. So first what we have to prove here means we have to prove that BDEF is a parallelogram. For proving BDEF is a parallelogram, we can use midpoint theorem because F and E are the midpoint of AB and AC. So by midpoint theorem, FE parallel to BC and FE equal to half BC. We know that means FE is parallel to BD as well as FE equal to half BD. We'll see that one. Proof. By midpoint theorem, FE parallel to BC, right? FE parallel to BC. Let us see that one. Okay, now FE equal to half BC. Half BC in the sense either BD or DC is possible. BD we required here, so it is equal to BD. So next line I'll write FE equal to BD. Similarly, if FE is parallel to BC, then FE is parallel to BD also. Now you see FE and BD, that is one pair of opposite side is equal as well as parallel in quadrilateral BDF, right? So we can write here one pair of opposite sides is equal and parallel. Therefore, BDEF is a parallelogram. Now we have learned that the diagonals of the parallelogram divided into two congruent triangles. We have to prove that to four congruent triangles only, right? So here, which is the diagonal DF? So we'll write here BDEF is a parallelogram we have got. So similarly, another parallelogram also we can write that. We'll complete also first. Now similarly, we'll complete that first. Now we have taken BDEF is a parallelogram first. Now which is the next parallelogram? DCEF. So what we got? The first parallelogram. Next is second parallelogram. Now the third one. Which is the third one? AEDF. So this is our first equation. This is our second equation. Right? Now what is the next step? Means we will use the theorem. Which is the theorem? Diagonal of the parallelogram divided into congruent triangles. So I'll write here. So first parallelogram is BDEF. BDEF. Now, if you consider triangle ABC, it is divided into four triangles. Which are they? First one, second one, third one, fourth one. What are the names? Triangle AFE, triangle DEF, and triangle BDF, and triangle CDE. So we should prove that these four congruent triangles only. So for that, we are considering the first parallelogram BDF, which is the diagonal DF, right? So if you consider the DF, these two triangle only, it is coming in the BDF parallelogram, right? So which is the triangle? I'll write here, triangle DFE, or I can write a triangle DEF. I am taking as a triangle DEF is congruent, because we know that it is a congruent. Now I'll give a hint for you, because DF is the diagonal there. Remember this, children, DF is the diagonal. That will be for us, because it's alternate interior angle concept we are using. So this letters will interchange. That means in place of D it will be F, in place of F it will be D. Understood? Now the third letter we should, which is the parallelogram we are considering, BDEF. We already got which is the diagonal DF. So the one side it is DEF, other side BDF. So which is the middle letter? It will be FBD. And I should write here triangle. We can use ASA because this is alternate interior angle. Once we have proved that it is a parallelogram alternate interior angle, this is a common side. So I can write here ASA. Right? Next. What is the next one? Similarly, DCEF is the parallelogram next. I'll write the same order, area, triangle DF only here. Now congruent I have to write, which is the parallelogram I have to consider, DCEF. See the diagram, DCEF, which is the diagonal D. So D and E will be interchanged. ED, right? Now triangle. Now which is the letter left? The C. Criteria is same only. Understood. What is the next step? One more triangle we required. One more pair also we required from AEDF. So this side I am making common, DF only. Now for AEDF, which is the diagonal, AEDF. F is the diagonal. F and E will be interchanged. Here F and here E. Instead of D, it is A. Right? Now again ASA. If we use this concept, this proof is very easy only. Right? So now we got that these three pairs are equal. From this, if you check LHS, we got the same only. So that means these three triangles are congruent to one triangle. This shows that all are congruent to each other. That means what we can write here? Triangle DEF congruent to triangle FBD, congruent to triangle EDC, congruent to triangle AFE. Means what? The triangle ABC is divided into four congruent triangles. Hence proved. So here the hint what I want to give on that, we can use the concept very easily. Only you have to keep the order. Otherwise what will happen? Each time you have to repeat the criteria. That is not required. Triangle DEF we should take and identify the diagonal. The diagonal order will interchange. D and F will interchange here, F and D. And in between, instead of E, we should get a B. Similarly, for the second parallelogram, D and E is interchanging. Right? Third parallelogram, F and E is interchanging. F and E are interchanged here. Got? So with this you can write easily this concept and you can easily finish this proof. With this today's class I am winding up. So what we have proved here, triangle ABC is divided into 4 congruent triangles. Practice more. Thank you.